Our objective for today, I can simplify algebraic expressions using order of operations. Let's read together. 1, 2, 3. I can simplify algebraic expressions using order of operations. So today we have a new concept. So turn to your neighbor and let them know what the new concept is for today. Algebraic expressions, right? Okay. So at the bottom where your objective is written, circle or underline with red, simplify, and circle or underline with green where it says algebraic expressions, please, in your Cornell notes at the bottom left. All right. So we've been already working with expressions. We worked with some polynomials, but before we go any further, I want to go ahead and explain expressions so that everybody is clear as to what we're talking about. Because I still sense some of you are getting confused. So pens down, eyes up here, please. Here we go. I'm going to introduce expressions in a different way, so see, maybe this will sink in, so everybody's attention on the screen. So let's say somebody wanted to come up to me and they said, Mr. Q, since I haven't been turning in all my homework, and you really helped with that tutoring last time and before we took the test, I wanted to get everybody in the class front row seats to a concert. And we're like, oh yeah. So I told everybody, all right guys, we're going to a concert, so let's just pack up. We're gonna ask, I already got you guys' permission slips, let's go. I have a bus ready for us. So we go to a concert, we get there, and everybody's like pumped up, right? And then we get there, and then all of a sudden we're like, whoa. And we're like, oh my goodness. And I was like, really, Joe? You got us stick stuff? So anyway, all of a sudden some of us were right there, and then we're like, okay. But then all of a sudden we hear, and then we're like, okay, that's a little bit better. All right, okay. So we're getting more into the concert, right? Now, expressions are very similar to what we just saw. Expressions are similar because, focus please, focus. First we started with what kind of music was this? Country, and then all of a sudden it turned into what? Rap or hip hop. So in your education, check this out. Expressions are the same way in math. When you started in elementary, all the way through, most of it was what? Numerical with operations. Is that correct? But now that we arrive at algebra, now we have some other stuff. So let me clarify just to make sure that we got it. So when we were in elementary, we were looking at numbers, operations. Is that correct? But then all of a sudden we get to algebra, we have numbers, operations, and now what did we introduce? Variables. Can you tell the difference now from numerical to algebraic expressions?
Oh, yes.
Yes? Okay. So, with that said, in your Freire model, get that in front of you. Algebraic expressions, what are they? The definition says, expressions that contain variables, constants, numbers, and operations. Okay? Examples, write these down, please. X plus 3, m minus 7, d times y, k squared divided by 5. Write those down, please. Non-examples. We have x plus 3 equals 10, 15 equals m minus 7, 2 times y greater than or equal to 12, and 2 is greater than or equal to k squared plus 5. Divided by 5, sorry. Copy that. All right, so according to the definition, pens down please, really quick. Here it goes. It says, according to the definition, it says that algebraic expressions are expressions containing variables, numbers, and operations. Do we have that here?
Yes.
Yes. So think about these questions. Why do you think, specifically, why do you think these are, think about it, don't say it out loud, why do you think these are non-examples? Think about it first. All right, talk it over with your neighbor. Why are these non-examples? Thank you. So did everybody see that these are non-examples because they have equations and inequalities? And what are we looking at right now? Expressions. We're looking at expressions. So with the processes that you're doing with simplifying expressions today and in today's homework, I don't want to see equal signs, right? You're just going to simplify step by step your expression until you come to a simplification at the end. So what is the most important thing to remember about algebraic expressions? They are what? Expressions only. They do not have what? Equal signs. What other thing? They have variables, constants, and operations. Variables, constants, and operations. So two things to remember. They do not have equal signs or inequality signs, and they have variables, constants, and operations. Okay, so we're clear with algebraic expressions. Let's continue. I give you guys some steps to follow. Here you go. Step 1. To simplify algebraic expressions, use the order of operations. Step 2. Use the cat properties to combine like terms. And step 3. Simplify. So, order of operations, right next to it, I want you to write P, E, M, D, A, S. Okay? With red, I want you to circle the word use, underline order of operations. Circle the word use for the second step, underline cat properties, and with the wiggles, combine like terms. And at the end, simplify. Okay? Now let me go back up to PEMDAS, order of operations. I want you to circle with blue M and D, and with green A and S. Now, the reason being, I'm going to show you why in a little bit, but these two have to be looked at together, and these two have to be looked at together. They're not individually done, okay? Because some of you get confused that you think, oh, I need to do this one first and this one. No, I'll show you that in a little bit, okay? So, steps, use order of operations. Step 2, use your properties to combine like terms. Step 3, simplify. Step 1, use order of operations. Step 2, use cat properties to combine like terms. Step 3, simplify. Step 1, use order of operations. Step 2, use cat properties to combine like terms. Step 3, simplify. Step 1, use order of operations. Step 2, use cat properties to combine like terms. Step 3, simplify. Okay, tell your neighbor the steps, please, without reading. See if you got it. All right. Here we go. So let's continue. So cat properties, yesterday we covered those, right? And you did those for homework, and we know what they are. We know that it's the commutative, associative, and distributive property, okay? So with that said, I gave you guys also a diagram for order of operations, and I put it on the Q side, right? And what is order of operations? Well, order of operations is a set of steps that we use to simplify expressions. Because if we did not have those in place, everybody would do whatever they wanted. It's kind of like this. Check this out. I'm going to put this to you this simple. Let's say that the state of California no longer wanted to enforce the age requirement for driver's license. So imagine that. Imagine giving a brand new car to a 13-year-old, 14-year-old. What is the first thing some of you would do? Off-road and go right. So therefore, imagine how some of us that actually drive really nicely and we have music in the background like at Walmart. Right? Anyways, yeah, so what I'm saying is that in order for everything to be organized and everybody to come to a consensus as to a simplification of an expression, that's why we need the order of operations, okay? So here we go. So with that said, here goes the order of operations. Order of operations, the very first thing we need to look at is parentheses and powers. parentheses and powers. So now, underneath the word parentheses, write grouping symbols. No, I'm doing this in black. Grouping symbols. And underneath that grouping symbols, let me give you a lot of the examples of grouping symbols. Everybody's familiar with the parentheses, right? Okay. The other set of grouping symbols are these, the brackets. So remember the brackets. Okay. Another type of bracket is this one, that it looks just like a part of a box or something. It looks like this. So that's also a grouping symbol. Write these down, please. Another grouping symbol that some of us maybe never thought about is this one. What is the name of this? Radical. Exactly. That's also known as a grouping symbol. Another one that also we use often, but we never really thought about it, and this is the simplest one. Check this out. The fraction bar. Fraction bar. Fraction bar is also known as a grouping symbol because we group the numerator with the numerators and the denominators with the denominators. Everybody with me? Right. I know. You never think about it, but that's what it is. Because many times when we don't see the fraction bar as a grouping symbol, we start doing operations back and forth and we make mistakes. Okay? So here we go. So the first step that we're going to be looking at are all my grouping symbols, and then from there we're going to look at powers. On powers, I want you to put a little 2 above the S so that we remember that powers are what? Powers are what? Exponents. We're looking at exponents. Step 2. For step 2, we have multiplication and division, and we're going from left to right. But I want you to circle, guys, with red. Circle where it says whichever comes first. Whichever comes first. Because many times in the expression, sometimes there's multiplication at the end and division at the beginning. But since you guys remember PEMDAS or multiplication and division, you usually do multiplication first, but it's on the far right, and that's incorrect. Okay? So multiplication and division from left to right, whichever comes first. Tell your neighbor what you're going to do when multiplication and division comes. From left to right. From left to right. No. No. And the last step, we're going to be looking at addition and subtraction. And again, with red, oh, it doesn't, you can't tell. Well, just with your pencil, maybe your pencil, you can tell with your pencil. Here we go. Circle where it says whichever comes first from left to right, addition and subtraction. With your pencil, when you use your pencil, it shows a little bit the glare of the light. You can see it. Okay, that's fine. So whichever comes first. So don't forget that, please, because if you forget whichever comes first, you're going to start making mistakes. Okay? So with that said, let's go to our first example. Copy this down. Example 1, A and B. If you want, leave about 2 to 3 lines in between. So check this out. This is what I do when I get to simplification, and I'm going to ask you to do the same. Because many times when we get to a test or a quiz, some of us start doing stuff so fast that we forget our steps. So in order not to forget steps, on the right side, I want you to write PEMDAS. And I hope you remember that, right? Okay? Now, some of your teachers introduce it like, please excuse my dear Aunt Susan. Right? Sally. No, it's I don't have a Sally. So it's Susan. Yeah. So, therefore, we need to have this handy so that when we simplify, we keep going back to it. You need to rewrite it every time or at the top of your page that you're going to be working with. Everybody with me? So here we go. Let's work this one out. Do I have any parentheses or grouping symbols? No. Do I have any exponents? No. So next, I'm going to circle with blue so I won't forget. multiplication and division. Do I have any multiplication and division? Yes, so I'm going to work my way from left to right. So let's see. Here's multiplication. So what is negative 2 times 3? Negative 6. And I bring the rest down. 15 and the plus 1. Next, with green, I'm going to circle addition and subtraction. Do I have any addition and subtraction? Yes, I'm going to work my way from left to right. So therefore, what is 15 minus 6? 9. What is 9 plus 1? 10. And we're done. Who noticed that I did not use equal signs? Why aren't we using equal signs? Because we're looking at what? Expressions, not equations. And I don't want you guys to get confused back and forth. That's what simplify is when you reduce it to lowest terms. Now it clicks. Some of you like. All right, here we go. Let's do number 2 together. And once again, I'm going to go ahead and write my order of operations again just to keep myself organized. And I'm going to start with parentheses. Do I have any grouping symbols? No. Do I have an exponent? Yes, so I'm going to work the exponent out, and I'm going to do that in red. What is 3 squared? 9. Okay? I bring everything else down. The 12, the 10, the division, and the 2. All right. From there, I'm going to circle my multiplication and division. Do I have any multiplication and division? Yes, I have it right here, but I'm still going to scan from left to right. So I'm going to start from the left. Nothing here, nothing here, nothing here. What is 10 divided by 2? 5. And I bring everything else down. 12 plus 9 plus 5. At the end, with green, I'm going to circle addition and subtraction. Do I have any? Yes, I'm going from left to right. So what is 12 plus 9? 21 plus 5, that's 26. See how that worked? Okay. Yes, sir? Try not to, because I'm trying to. Did everybody hear the question? Can we put 21 plus 5 equals 26? Okay, this is in itself, it's true, right? However, I don't want you guys to get confused that right now we're still looking at expressions. I want you guys to get it clear in your head what expressions are and what equations are. Are we there? So please work your way down all the way till you simplify it to the lowest term. Okay? Okay, let's continue. Copy. No, it was example 1A and B. Oh, actually, this is example 1C. 1C. Copy that, please. All right, let's work this out together. Here we go. I'm going to write my order of operations. PEMDAS, so I can keep myself organized. So here we go. I'm going to start. Do I have any parentheses or grouping symbols? Yes, the bar is a grouping symbol. That tells me to do one section first all the way till it's simplified. Everybody with me? So I'm going to start with the numerator first. So therefore, now that I'm at the numerator, now I'm going to start again. I'm going to scan through this, and I'm going to say, do I have any parentheses in the numerator? Yes, but can we do anything to simplify it anymore? No. Let me go to the next one. Do I have any exponents in the numerator? No. So therefore, I go to and I circle multiplication and division, and I'm going from left to right on the numerator. Do I have multiplication and division? Yes. So what is 2 times negative 4? So here I want you to draw an arrow, sketch your bar, and this is negative 8. And bring over the plus 22. So far, so good? Okay, with green, I'm going to circle the addition and subtraction, and I'm going from left to right on the numerator. So once again, negative 8 plus 22. Negative 8 plus 22. What is that? Negative 8 plus 22, that's 14. 14. Did we simplify already completely that section of our grouping symbol? Yes. Now we're going to focus now on the denominator. So once again, I'm going to get started with my PEMDAS for the denominator. Do I have any parentheses down here?
No.
Exponents? Yes, I'm going to do that in red. So what is 4 squared? 16, and I carry over the minus 9. There it is. Do I have, and I circled the multiplication, do I have multiplication and division? No, I skipped that one. I go to addition and subtraction in green, and I'm working from left to right. 16 minus 9, that's 7. So, and what is our last step from our notes? Simplify. So what is 14 divided by 7? 2 over 1, which is 2. So far, so good? Fairly simple? Yeah, right? If you follow your process through every time, it would work. But once you start rushing your steps, guess what? You're going to make mistakes. Once again, I don't want to hear, oh, Mr. Q, I can do it in my brain. I don't want to hear that. I want you to show me the steps, please. All right, let's do this next one, please. Okay, copy that. Do that one by yourself. Be careful. This one is a one of those that they try and throw a little curveball at you. So think it through and do it step by step, please. Here it goes. Let's do this one together. Write your order of operations, PEMDAS, and like I said, be careful with these. Even though they look simple, some of us that rush through our order of operations, we make mistakes. Here it goes. Do I have any grouping symbols? No, just right here, but can we simplify anything else on the numerator and denominator? No. Do I have any exponents?
No.
Multiplication and division? Yes, it's pretty much throughout. We're going from left to right. So I'm going to focus from left to right on these two. 8 divided by 1/2, or 8 over 1 divided by 1/2 becomes 8 over 1 times the reciprocal, which is 2 over 1. So let's see. What is 8 times 2? 16 over 1. What is 16 over 1? 16. Now I can bring down the last part, which is times 3. So let's see. What is 3 times 16? 48. Like I said, be careful with the ones that look the simplest, because those are probably the ones that you're going to have difficulty with. So just make sure you go step by step and read exactly what it says. Don't rush through. Okay? Okay, let's do another one. Copy that one, please. Example, this is it's very similar to what we did, but now it has a different grouping symbol. It says 3 times square root of 50 minus 1. 3 times square root of 50 minus 1. I'll give you a head start of about 30 seconds, and then I'll go over it to see if you got it. Okay, go. All right, let's go over this one. Let's see what we got. I write down my order of operations, and I'm going to start, and I'm going to say, do I have any parentheses or grouping symbols? Yes, this is the grouping symbol. Remember we wrote it down? So that we need to simplify everything inside of the grouping symbol. So what is 50 minus 1? So then we're left with 3 times square root of 49. Can we still simplify this grouping symbol? Yes, what is the square root of 49? 7. And what is the 3 doing here? It's multiplying. I'm going to do that in red so you can see it. Times 3. So then at the end, do I have multiplication and division? Yes, right here. So therefore this is 21.
Oh, I thought the 3 was the exponent.
No, it's a multiplication. Okay? Copy this next one down, please. Copy that one down. See if you can do that one by yourself now. You already know the steps. Follow your steps. And while you're copying it down, I'm going to write the homework so you can see it. Homework is found on page, what is it? 1 through 35 odd, number, and 8, and 28. Okay, guys, as you're finishing copying this and copying the homework, the only thing that was left on this lesson was to go over combining like terms, but we already went over that. I want you to revisit that section, read it. Listen to what I'm saying. I want you to read combining like terms section on that same lesson. And so like that, if you have any questions for the rest of the problems, okay? Tell your neighbor what you're going to do aside from that. All right. Have a good one, everyone. Enjoy your homework. I'll see you guys tomorrow.